Lesson 9. Gradient, Magnetic Flux. Section 9.3. Magnetic Flux Lines. Let's suppose that there are two magnetic point charges with positive m and negative m Webers respectively. The composite magnetic field strength H is obtained by the vector sum of H1 due to the positive m and H2 due to the negative m. The other charges of the pairs are assumed to be far from the point P and thus are negligible. By following the direction of magnetic field vectors, we can draw a line like the one in this figure. The magnetic field vectors are tangent to the line. Then, we can draw these lines. These lines emanate from the positive m, and terminate at the negative m. If both the point charges are positive m, then the lines are like these. These lines leave positive m, and reach negative m of their pairs. These lines are called magnetic flux lines. In section 2.1, the electric flux was defined as the total number of electric flux lines generated from a net charge. This definition is based on the fact that there is a net positive or negative charge in nature. In contrast, there are no magnetic monopoles in nature. No matter how a magnet is cut into pieces, every piece has an ns pair, and the magnitudes of magnetic charges are equal in each pair of poles. In any closed surface, the net magnetic charge is zero. Magnetic flux cannot be defined in the same way as electric flux is defined. Section 9.4. Magnetic Polarization. This is a model of a tiny magnet. A permanent magnet has many tiny magnets aligned in one direction. In some magnetic materials, called paramagnetic materials, the tiny magnets are directed randomly. When exposed to an outer magnetic field, they align in the same direction as that of the magnetic field. The magnetic dipole moment is expressed by this equation. The unit is Weber meter. Then the magnetic polarization is defined as the density of permanent or induced magnetic dipole moments. N is the number of dipole moments aligned in one direction in the differential volume dV. The unit is Weber per square meter. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.